Now that I have a large population of patients that have all the data attached for the studies we are concerned with, I could eventually look for similar cases. So let's say now I want to look for patients having similar conditions compared to mine. I can ask the system to run the so-called case resonance, which is the application currently being developed by Siemens as the basis of their decision support system. This application starts interacting with the large database and does some statistical analysis of the population to then display graphically the distribution of the patients. So this is what it is doing. Now it's filling in the graphical user interface. So here you see a first frame, a first interface where there is basic statistical analysis, distribution of population. You can navigate through a hierarchy of clinical features to then see corresponding distribution. But this is not the most, I would say, important feature of that application. That application then allows you to run similarity search. If my mouse works again. Yes, it does. So I can, for instance, now ask the system to look for patients having similar conditions based on a subset of criteria I'm interested in. So here I can specify from the clinical features that the system exposes various criteria I'm interested in. Could you press control? So I'm going to select a few ones. Let's say heart rate, elements of MR imaging, and then the maximum number of patients you want to get from the system for that particular cardiac study. Again, the interface interacts with the system. It measures similarity distances between the different patients and then renders graphically the result using 3 different visualization techniques. One is so-called tree maps. So here you have a set of squares of different sizes. Each square represents one patient. The larger the square is, the more similar the patient is. Then subsequently you can play with colors to display additional features. But what's interesting is that very quickly and graphically you can identify the 1 to 5 most similar patients. Once this is done, you can double click on the corresponding patient and you have access to his folder, and then you can compare on a one-to-one basis. So that is tree maps, but we also have another visualization techniques that is quite interesting, that is being used in social networks, which is a neighborhood graph. So here you have a graph. Each node is a patient, and the similarity distances are concretely displayed in that graph through distances between nodes. In red, this is my patient, my current patient, and the system is telling me that this one is the most similar. So similarly to what I did with the tree maps, I could double-click to open the patient records and compare. What's interesting with that interface is that you can also highlight clusters of similarities, so you can play with different graphical parameters to highlight these groups. You can filter the data, so you can indicate that you want to filter on a gender basis. So let's say I want to see only females in the graph. You can also then play with colors. So you can say, I would like to show age in the graph. So using this tool, you can quickly navigate through the whole population, investigate different criteria, and eventually discover why you have such groups and similarities. Last but not least, in terms of visualization techniques, we have the so-called heat mapper, which is very popular in genomics, where you have a matrix of patients against patients. Similarities are expressed with different gradients of colors, and when you obtain areas in the graph where the color is quite homogeneous, that means you have a cluster of similarity. So what you can do then is to, still from the clinical feature list, select a few parameters you are interested in, and then superimpose them onto the graph to eventually discover new knowledge. All right, so this is a set of tools and similarity search algorithms that you can use to investigate your whole population at the same time.